Let us take a look at this picture to understand how we can calculate the components of radial and cross radial acceleration. Okay, so here we want to find the components of radial and cross radial acceleration. Okay, so this is the formalism. OP is the radius vector, PP prime is the chord drawn in green ink which merges to the tangent. We all know that P and P prime are very infinitesimally close points. The point traverses from P to P prime in time delta t, and we want to find the component of acceleration along the radius and perpendicular to the radius. So the formalism is quite clear. We have in the earlier video proved that the component of radial velocity u is nothing but r dot, and the cross radial velocity v is nothing but r theta dot. They have been designated by these red arrows. At p we have radial component of velocity u and cross radial r theta dot. Now let us see at p prime what happens. We assume that at p prime we have increased radial velocity as u plus delta u and increased cross radial velocity at v plus delta v acting along the radius at p prime op prime and perpendicular to the direction of op prime. Quite clear? So we have the velocity at this point p, u and v, and at this point p prime u plus delta u and v plus delta v along radius and cross radius, that is perpendicular to the radius. Now let us draw at p prime these two arrows, red arrows, parallel. So this is the direction of u and this is the direction of v. So since OP and OP prime makes an angle delta theta, so the component u will make an angle delta theta with u plus delta u. Simple geometry, isn't it so? This is delta theta making an angle with OP and OP prime. So obviously since u acts along OP, and here we have denoted with this red arrow, this is parallel to this and this is along OP prime, so it will be delta theta. Quite clear? So what is the component of, what is radial acceleration? We know from the definition that radial acceleration is nothing but rate of change of velocity along the radius, rate of change of velocity along OP, the radius, isn't it so? So what is the velocity at p along OP? U. And what is now the velocity? Just see that now the velocity u is u plus delta u along OP prime and v plus delta v along the perpendicular direction of OP prime. So what is the change? The change is when you take the limit of delta t tends to 0 and we take the component of u plus delta u along this red line. So what is the component of u plus delta u along the red line? It is cos delta theta. Simple, since this is delta theta. But not only that, since v plus delta v is also the cross radial velocity and it will have a component along the red line, isn't it so? Let us extend this red line and try to understand. See, this red line can easily be extended. This is actually parallel to this line. So v plus delta v will have a component along this, isn't it so? Since this is delta theta, this is 90 minus delta theta, and since this is 90 minus delta theta, these two are perpendicular, so this is also again delta theta, and what will be this? This will be 90 minus delta theta. So the component of v plus delta v along this will be cos of 90 minus delta theta, well, minus sin delta theta, so this will be minus v plus delta v sin delta theta. The sense is in the opposite direction along this red line, extended red line. So this will be the rate of change of velocity along the radius OP. I repeat, just try to match with this figure minutely. We just wanted to find the rate of change of velocity along OP. Now what is the velocity along OP? It is u initially. What is the velocity? Now it is u plus delta u, but it is along OP prime. So what is the component along OP? U plus delta u cos delta theta. Not only that, but also the reverse component of v plus delta v, which will be minus v plus delta v sine delta theta. Actually minus v plus delta v this is v plus delta v cos of 90 minus delta theta, which turns out to be this. And original velocity was u. This is the changed velocity, so the change is it. The velocity changed from u to u plus delta u, but along up it has component this. So this minus u by delta t. And with the logic that cos delta theta tends to 1 and sine delta theta tends to delta theta, we may easily replace this by 1 and this by delta theta. And then we again use the logic that v into delta theta. This is quite obvious. We all know that as delta theta tends to 0, which is obviously the case, as delta t tends to 0, we can easily replace cos delta theta by 1 and sine delta theta by delta theta only. And then we use the logic that in these two terms, v delta theta is much larger than delta v into delta theta, because delta v into delta theta are the product of two very small quantities. So we should avoid delta v and delta theta in comparison with v delta theta, and we keep only v delta theta here. So this is minus v delta theta minus u only, and then we take the limit as delta t tends to 0. So what is the first term? This u and u cancels out. Delta u by delta t. This is du dt, isn't it so? And v delta theta by delta t becomes v d theta dt. Okay? And as we all know that u is r dot and v is r theta dot. That means u is r dr dt. Dr dt is written as r dot. This is the abbreviation we should know. So what will be du dt? It will be r2 dot, isn't it so? d2 r dt2. And what will be v theta dot? V is nothing but r theta dot. So r theta dot into theta dot becomes r theta dot square. So radial acceleration is nothing but r2 dot minus r theta dot square. That is the expression of radial acceleration. Now we move on to find the cross radial acceleration. What will be the cross radial acceleration? With this figure, we can easily find out that cross radial acceleration will be the rate of change of velocity along the cross radial direction. Now what is the cross radial direction? The direction perpendicular to the radius. So cross radial acceleration will be rate of change of velocity along this. So along this the velocity was v, and now what is the velocity? Along this direction, it is the component of u plus delta u along this, which is u plus delta u sine delta theta, isn't it so? Obviously, since this is delta theta, this is 90 minus delta theta, and this is sine delta theta. And what is the component of v plus delta v along this? Since this is also delta theta, this is delta theta, this is delta theta, this is delta theta. So the component will be v plus delta v cos delta theta, quite obvious. And then we subtract the original velocity v, which was along the cross radial direction. So this is the expression for cross radial acceleration. Velocity along the perpendicular direction, component is u plus delta u sine delta theta, v plus delta v cos delta theta, and the previous velocity was v. We subtract it, so this is the change by delta t. Now let us see what it becomes. As delta t tends to 0, we again substitute sine delta theta by delta theta and cos delta theta by 1, and this becomes v plus delta v minus v by delta t. Quite obvious, this v cancels out, and here also we again ignore this delta u delta theta quantity, which is much smaller than u delta theta. So we just keep u delta theta here and delta v here. So we have u delta theta plus delta v by delta t. We have u delta theta plus delta v by delta t. This v cancels out since this is 1 and this is only u delta theta. And what is u delta theta by delta t? As delta t tends to 0, it is nothing but u theta dot. And what is delta v delta t? It is dv dt. Okay. Now let us look at this u and v, which is u u is r dot, so this is r dot theta dot. And what is dv dt? This is d dt of r theta dot. So d dt of r theta dot, this is r theta dot, isn't it so? So dv dt is d dt of r theta dot, and this gives r dot theta dot plus r theta double dot. So this is 2r dot theta dot plus r theta double dot. Now a word about cross radial acceleration. Although the amount comes out to be 2r dot theta dot plus r theta double dot, the cross radial acceleration turns out to be 2r dot theta dot plus r theta double dot. We intend to express is at 1 by r d dt of r square theta dot for a special reason. As I said, that Kepler used this cross radial acceleration to establish planetary rules, and in case of central force we have cross radial acceleration to be 0, so that this r square theta dot terms comes out to be a constant of motion, which is actually angular momentum. R square theta dot is nothing but r into r theta dot, and since r theta dot is the cross radial velocity and r is the radius vector, so this is the angular momentum and it is conserved. So we express cross radial acceleration this way.